Hello, and welcome to Dividing with Scientific Notation. Today we're going to, ironically, divide with scientific notation. Now, yesterday we learned how to multiply with scientific notation. And if you'll recall from yesterday, we did two things. First, we looked at our regular numbers that aren't to any power, and we multiplied them. Then, we dealt with our powers of 10, and we multiplied those, getting 10 to the 8th. And the last thing we did yesterday was we made sure that we had scientific notation in our answer. Since 12 times 10.8 is not scientific notation, we remembered to adjust it to 1.2 times 10 to the 9th. We're going to use a similar process today when we're doing our dividing. We're going to deal with our factors, we're going to deal with our powers of 10, and we're going to adjust to make sure we're still in scientific notation. Take, for example, this problem. I can see right here that I have my factors 6 and 3. I can see that I have powers of 10, and I can see that I'm doing division. Well, just like yesterday, I'm going to handle it piece by piece, part by part, and come up with the correct answer. So the first thing I'm going to ask myself is, what is 6 divided by 3? Well, 6 divided by 3 is 2. Now I'm going to focus on my powers of 10. I have 10 to the 7th divided by 10 to the 4th. Now in my mind, I remember that when I have 10 to the 7th divided by 10 to the 4th, it really means that I have 10 to the 7 minus 4, or 10 to the 3rd. So I will write this as 2 times 10 to the 3rd power. Then I'll ask myself, is this scientific notation? Meaning, do I have right here a factor that is between 1 and 10? And do I have a power of 10 to an integer exponent? This is in scientific notation, so I'm already done with this one. That wasn't too bad. Now I have here a little more challenging problem. I say it's a little more challenging because this factor is a decimal being divided by this factor, which isn't. But that's okay, I can do that. I also still see that I have a power of 10 and a power of 10. Again, I'll approach this the same way I did the last one. 8.4 divided by 2. 8.4 divided by 2 is 4.2. Now I can deal with my powers of 10. I have 10 to the 5th being divided by 10 to the negative 3rd. In my mind, I remember that that's going to be 10 to the 5th minus negative 3, or 10 to the 8th. When I'm subtracting a negative, I have to remember that it's like I'm adding a positive. So I would write this one as 4.2 times 10 to the 8th power. The last thing I'm going to ask myself is this scientific notation? Well, it is, because I have a factor that is 1 to less than 10, and I have times 10 to an integer power. Now we get to one that's much more interesting. I have here a factor of 4 being divided by a factor of 8. Well, 4 divided by 8, I'm going to write that as the decimal 0.5. And again, I have 10 to the power of negative 3 being divided by 10 to the power of negative 6. So I ask myself, 10 to the negative 3 divided by 10 to the negative 6th, that's like saying 10 to the negative 3 minus negative 6. Negative 3 minus negative 6 is positive 3. So I will write this as 5 times 10 to the 3rd power. And then I ask myself, is this scientific notation? Oof. No, this is not scientific notation. For this to be scientific notation, the factor has to be between 1 and it has to be less than 10. So it's got to be 1 or greater and less than 10, and 0.5 is not 1 or greater. So just like yesterday, we're going to adjust to make sure that we have real scientific notation. For that to happen, this decimal is going to have to move, and we're going to end up with 5 times 10 to some power. Now the question is, should I end up increasing this 3 to a 4, or decreasing this 3 to a 2? Well, as we've talked about before, from 0.5 to positive 5, this we multiplied by 10. The place value got 1 bigger going from here to here. Which means in order to keep the same value, this place value has to go 1 place value smaller. This will be to the second power. Another way of thinking about that is to realize that 0.5 could be written as 5 times 10 to the negative first. So I could have rewritten this first statement as 5 times 10 to the negative first times 10 to the third, which is 5 times 10 to the second power, because negative 1 plus 3 is 2. So that's another way of thinking about it. I like to just look at it as this has to get 1 place value bigger, so this has to get 1 place value smaller to maintain the same value. So overall, dividing scientific notation is actually pretty easy. We have 3 basic steps. 1, we divide the factors. They're just numbers and we can divide numbers. Number 2, we divide the powers of 10, which means we subtract the exponents. Remember, when you're subtracting a negative, it's like you're adding a positive. And on number 3, we adjust the answer to be in scientific notation. Very frequently when we perform operations with scientific notation, we get results that are no longer in scientific notation, and we have to adjust. But it's pretty easy to adjust it if we just remember, if we adjust the factor place value, we have to compensate by adjusting the power of 10 an equivalent place value.